Welcome to today's video. Today we're going to be focusing on translating algebraic expressions into words. There's not a big note sheet that we want you to take, but I need you to make sure to pay attention to this video just so you can get the key words and the key phrases that we're going to need to know.
Hello everyone, and welcome to this lesson on algebraic translation. Now, our aim for this lesson is how can we translate written expressions and equations into numerical form. So basically, we see it in written form and we want to write it in terms of numbers and variables. Now, before we can do that, we have to lay the groundwork here, and there's a few things that we need to know so that we can use them when we get to doing the actual translations. Now, if we had something like 7 plus 5, verbally, we could express this, for example, as the sum of 7 and 5, and we would be done. But what if instead of a 7, we had a variable, we had the letter x there? Instead of saying the sum of 7 and 5, we would say the sum of a number and 5, because x is a variable and it could represent any number, so we're just going to call it a number. And even though x is the most commonly used letter, this applies to any letter in the alphabet that can be used to represent a variable, which is just some unknown value. So let's translate 10 plus a number. So again, it's an expression, so we have the number 10 plus, we know it's just addition, and then a number is just some unknown, we'll call it x. So that translates to 10 plus x. Now what if we add the statement 10 more than a number? Now we should know that more than is associated with addition, so our sign is not going to change. So let's think about this one differently. We have a number, some unknown number, some variable, and this phrase represents 10 more than whatever that number is. So in this case, we're going to start with the variable and then add 10 to it. Now since this was addition, and because addition is commutative, the order didn't actually matter. But let's take a look at an example now using subtraction. So now let's look at 6 less than a number. So again, we see that word then. So we have 3 parts here. We have the number 6, we have less than, which we know is subtraction, and then a number, we'll call it n. Now this phrase represents a value that is 6 units smaller than whatever our number n is. So to find that number, we would have to take n and subtract 6 from it. So in cases like this, the second term comes first and the first term comes second. We have to switch the order. Now this is the case when we see the word then. And we're going to say that then is a switch word, which means that the operator stays in the middle, but the order of the first term and the last term is switched. So the way that it's written, the actual expression will be in reverse order. Moving on now, if we have the phrase the difference of 3 and a number, we could easily translate this. Difference is subtraction, and we have 3 minus some number, we'll call it p, so 3 minus p would represent this phrase. But what if instead of the difference of 3 and a number, we had the difference of 3 and twice a number plus 1? So now instead of p, we have to represent that whole expression, which we can call 2p plus 1. And we can enclose this individual expression in parentheses. So when performing algebraic translations, you can use parentheses to separate independent groupings. And now let's look at a number divided by 3 is 8. So we have a number, let's call it t, and we're dividing it by 3, so let's use it as a fraction, t over 3. And when we say is 8, that just means that it equals 8. So be aware that the word is or is equivalent to just means equals to. So a quick recap before we get into the examples. Remember that a number is just a variable. The word then we call a switch word. Use parentheses for independent groupings, and is means equal to. So now we're ready for a few examples. So first, let's translate the phrase, the product of a number and 9. So we know that product just means to multiply, and what we're multiplying together is a number, we'll call it n, and the number 9. Now n times 9 is fine, but we'll more commonly see it written as 9n without the multiplication sign, but that means 9 times n. Next, we have the phrase half a number decreased by 12. Decrease by means to subtract, and now the first term is half a number, we'll call that number x, and half of it means dividing it by 2. So we have x over 2 minus 12. So that expression is the translation of that verbal phrase. Next, we want to translate the phrase 3 times the difference of a number and 1. So basically, we're multiplying 3 by another expression, whatever the difference of a number and 1 is. So you have two separate parts here. So we have 3 multiplied by an independent group, in this case, the difference of a number and 1, which we'll call p minus 1. So this is an example of how you can use parentheses to separate independent groupings. And if you don't use the parentheses here, it will not be correct.